Welcome back, you sentient bags of water and electricity. Welcome to the Existential Nerd's Guide to Everything, the show where we take the fabric of reality, hold it up to the light, and realize it's full of moth holes. I'm your host, Maple. Right now, I am magnetized to my chair, mostly by the force of sheer procrastination. And today, we're talking about magnets.
I know, you're thinking of that old internet classic. Well, it turns out, for a long time, the best answer science had was something like, we don't really know for sure, but if you get them hot enough, they stop working. But you know what? That's old news. Because some folks over in Germany just decided to rewrite the rules of physics using, and you're gonna love this, lasers.
Okay, so let's get into this. The traditional way to change a material's magnetic properties is, to put it scientifically, to cook it. You literally have to heat it up, basically melting the magnetic order right out of it. It's the kill it with fire approach to data storage. It's very caveman. Me make rock hot, rock forget memory.
And the contrast is it's striking. The old way is all brute force. It's slow, it leaks heat everywhere, and it wastes a ton of power. But this new way, it's elegant. It uses light to do the same thing, but it's ultra fast, incredibly efficient, and has the kind of surgical precision you'd see in a heist movie. It's a complete game changer.
And this brings us to our intrepid scientists. We're talking about researchers at the University of Konstanz, which, you gotta admit, sounds like a place where they definitely have a secret underground lair. They're the ones who figured out a way to basically hack matter. They decided to skip the whole making rocks hot phase and just went straight for the high-tech solution. So this is their setup. They took common iron ore, hematite, the stuff we literally dig out of the dirt, and they shot it with these ultra-fast laser pulses. Now, the goal wasn't to burn it. No, that would be way too easy. The real goal was to completely reshape the material's magnetic fingerprint. And get this, they did it at room temperature. Do you realize how rare that is in physics? Seriously. Usually when someone discovers a new quantum state, the fine print always says, at negative 273 degrees Celsius. But these guys? They're doing it in everyday conditions. They are basically Jedi. They're waving a laser and telling the material, this is not the magnetic field you are looking for. They are rewriting magnetic memory without even breaking a sweat. So how are they pulling this off? Well, the secret lies with the mysterious entity, the prime suspect in our little case here. It's a particle, or to be more precise, a quasi-particle known as the magnon. Come on, doesn't that sound like a villain straight out of a Marvel movie? Beware the wrath of Magnon.
But no, a magnon is a ripple in electron spins. Just imagine the magnetic field inside a material is a totally calm sea. A magnon is just a wave traveling across that sea. So here's the crucial part. These magnons carry magnetic information, and if you can control the waves, you can control the whole sea.
So how does this all build into what I'm calling the digital heist? This is the step-by-step process for hacking matter with just a flash of light. It's a really sophisticated operation, but the concept is actually beautifully simple. All right, here's the plan. First, you pick your target, a regular old hematite crystal. Second, you bring your tool, those ultra-fast laser pulses. Third, you make your move. Now, instead of just tickling the small magnons, you use that laser to excite these special, high-energy magnon pairs. And fourth, the payoff. Those energized pairs create a cascade, influencing all the other magnetic waves and rewriting the material's entire magnetic fingerprint. Boom. And on that note, we have to pause for a moment to hear a quick word from my most reliable informant. Yep, interrupting this science lesson for a moment of desperate self-promotion. If you enjoy hearing about how lasers are slowly taking over the world, please subscribe, rate the show, leave a review saying, this host has a magnetic personality, or maybe, this host creates a repulsive force. I really don't care, just engage with the content. Because if you don't review the show, I'll have to assume you are a disordered electron spin, and I will send the University of Konstanz to laser you into alignment. Okay, we're back. Back to our German laser wizards, we've established how they did it, but the big question is, why does any of this matter? Why should you care that a rock got zapped in a lab somewhere? Well, because our entire digital life is based on magnetism. Hard drives, servers, the cloud, it's all just flipping tiny magnetic switches on and off. Everything you stream, everything you save, everything you post exists as a magnetic state on a physical device somewhere. The current method of flipping those switches generates a ton of heat, which limits speed and wastes a ridiculous amount of energy. But this new light-based method, it happens at the speed of femtoseconds. For a little context, that's a quadrillionth of a second. It's a speed that modern electronics can only dream about.
So the payoff is huge. We are talking about greener computing that generates way less heat and uses less power. We're talking faster devices with memory and logic that operate at terahertz speeds. Better medical tools, like wearable sensors that don't need bulky cooling systems. It even makes quantum research more accessible since you don't need all that expensive cryogenic equipment. It means computers get faster, cooler, and less likely to melt the polar ice caps.
Ultimately, what they figured out how to do was tickle iron ore into submission with a flash of light, changing its fundamental magnetic DNA on demand. And I, for one, welcome our new laser-wielding overlords.
This explainer was produced by the indomitable FireflyHaku. Now, if this show were a piece of iron ore, FireflyHaku would be that ultra-fast laser pulse. They are the high-frequency energy that rearranges my chaotic rambling into a coherent magnetic fingerprint. Without them, I'm just a random collection of noise and spin. So thank you, FireflyHaku, for always keeping the signal clear.
And of course, thank you for listening. The case of the laser-tamed magnet is closed, but it leaves us with one final nagging question. What other laws of physics are just waiting for a flash of light to rewrite them? Try not to get demagnetized out there.